Okay, good morning, welcome. Sorry for that rude awakening. Let's go ahead and get started. Kudos to everyone who's here for the 8:30 a.m. session. Good job. Welcome. My name is Brian Sarasi. I'm a senior program manager on the Windows Server team. I've been with the Fast Track program since its inception. I've also been a part of the Hyper-V team since its inception as well. So I was part of the Hyper-V version 1, 2, and 3 launch and program, which was now, Windows Server 2008, Hyper-V and Windows Server 2008 R2, and then Hyper-V and Windows Server 2012. And the session today is around Hyper-V Cloud Fast Track. I'll kick off the session this morning. We also have with me Adam Fazio, who's one of the lead architects over the design architecture. Over the design architecture of Fast Track. We also have Lavanya Krishnan, who is a program manager on the Fast Track team as well. So our objectives and goals today are as follows. The first is to really be able to walk out of here being familiar with the benefits and talking points around what is Microsoft Private Cloud Fast Track. You may also hear me occasionally call it Hyper-V Cloud Fast Track. That was its previous name. It is the same program, it's the same initiative, but we changed it to Microsoft Private Cloud Fast Track to kind of indicate it's more than obviously just Hyper-V. It's also the whole system center stack, and it's also the whole hardware, compute, network, and storage stack from our OEM partners as well. The second key goal or objective is to understand the underlying technologies. At that point, I'm going to turn it over to Adam, and he's going to go into a technical deep dive of the different architecture designs and components that make up the Fast Track architecture. And then the final goal is the ability to discuss the value proposition, both business value proposition as well as the technical value proposition of the Private Cloud Fast Track program. And to do this is our agenda. I'm going to start out talking about the program strategy and overview. We're going to then go into the technical overview. We'll talk about the different solution breakouts. So this is the version 3 of Fast Track, which is launching this week here today at MMS. And we have new solutions that are coming to market based on version 3. So we'll go into a solution overview and talk about those as well. And at the end, I'm going to bring up Lavanya, who's going to do some demos around some tools that support Fast Track. And then finally, we'll just do a wrap-up with an overview again. So let's get started. This is the way we kind of position what Fast Track is and kind of where it plays. So if you look at the chart here, on the horizontal at the bottom, it's a little atypical. We actually have high deployment time on the left side and low deployment time on the right side. And on the vertical spectrum, we have low level of pre-integration on the bottom and high level of pre-integration at the top. And obviously there's custom do-it-yourself guidance out there today. Originally, we had some content called SVAM, and there's a lot of Microsoft guidance, as well as third-party and partner guidance out there as well, that talk about if you want to lay down Windows, if you want to lay down System Center to build a private cloud infrastructure, here's some things to think about, and here's some design choices, and then go do it yourself. Now, this type of do-it-yourself guidance is, from a deployment time perspective, very high. It's going to potentially take you a lot of time because it's not pre-built, it's not pre-integrated, and it's not pre-tested. And then the level of pre-integration, obviously, for the same purposes, is low. None of this has already been integrated together. None of it's been brought together. Now, the opposite end of the spectrum, we have what we call our Hyper-V cloud service providers. So these are our partner service providers who are providing cloud services based on Windows technology, based on System Center technology, but the end customer essentially just deploys their workloads to the cloud environment and doesn't necessarily have anything on site and doesn't necessarily need to manage or worry about the integration or the build out. Obviously, from a deployment time, very low. There's nothing to deploy on site. Level of pre-integration, very high. The hoster has already done all the work and all the heavy lifting. We position, and here it's listed as Hyper-V Cloud Fast Track, or we position Microsoft Private Cloud Fast Track somewhere in the middle. The fundamental goal of Fast Track is to have the best patterns and practices of private cloud design from Microsoft and our hardware partners. So it's the entire stack. This is not just Microsoft's way of doing things. This is the entire compute, networking, storage, Windows Server, virtualization, and System Center stack integrated together. And our goal here is to have a common design, a common architecture that we adhere to that we partner with our OEM partners. We not only do it on paper, but we physically build out the infrastructure, and we test and validate it end to end. So the goal here is to be able to deliver a solution from an OEM that's been pre-integrated, pre-validated, pre-tested, and ready to go. So the deployment time is reduced, the level of integration is increased. And that kind of leads into the key value propositions, which I've already alluded to. Number one is speed deployment. You can deploy quicker and faster because we've already tested the different components. It's not a guessing game. You have 15 different design choices. We've narrowed it down and we've validated the Microsoft best and recommended choices for different scenarios and different market segments. The second is reduced risk. Because it's pre-validated, because we built out the thing soup to nuts, because we have repeatable build guidance, we're assured that basically the risk is going to be reduced, it's going to work upon deployment, and the troubleshooting and the time that you have to take to do the integration is going to be reduced. And then the flexibility and choice. We know there are a lot of different private cloud environments out there, third-party platforms out there. One of the key things that we bring to the table is different vendor options. And with those different vendors, they all have different business and technical value propositions that we encourage them and allow them to light up. So when we look at some third-party vert platforms, it's one OS, it's one, well, in our case, it's still one OS, but it's one compute vendor, it's one networking vendor, and it's one storage vendor. As you see when we go through here with Microsoft and our great partnership with multiple partners, multiple OEMs, multiple manufacturers, we have a lot of different solutions. So if your customer's a Dell shop, we have a Dell Fast Track. If they're an NEC shop, a Fujitsu shop, an IBM shop, a Hitachi shop, an EMC shop, a NetApp shop, a Cisco shop, we have solutions for all these different platforms and all these different hardware vendors. So we have flexibility and choice in what is out there and what's available. Okay, so some of the key architectural principles, as I mentioned, we start with the compute, networking, storage. This is not just the System Center way. This is how System Center integrates with these key hardware technology components. On top of that, we obviously use Windows Server. This is version 3, so we're talking about Windows Server 2012. Then we have the System Center management stack on top. In version 3, we're using System Center 2012 Service Pack 1. And then we have the partner value add technology. By default, this is the integration components, the integration services for Operations Manager, as well as the Pro Packs from Virtual Machine Manager or for Virtual Machine Manager. The goal here is that Operations Manager, Virtual Machine Manager, the whole System Center stack has knowledge and control over the hardware stack as well. So again, it's not a bunch of disparate components, it's full end-to-end integration between the management stack and the hardware profile as well. And these are the typical tenets or the typical value propositions of any private cloud. So, and we hold on to these very dearly. So things like pooled resources, elasticity. Of course, we need continuous availability, no single point of failure. Predictability, usage-based. So we do chargeback, reporting, modeling, so you understand what resources are being consumed by what divisions in your company. That goes hand in hand with multi-tenancy. Of course, we're not referring to multi-tenancy as multiple customers on the same private cloud, but instead, again, multiple divisions or multiple organizations. So you understand, hey, the finance department is using this amount of my private cloud resources, while the research and development department is using that amount. And then, of course, secure and self-service. And self-service, we believe, is key to any private cloud environment. And the goal here is really to separate the application owner from the IT professional that's managing the physical infrastructure. Of course, we all know in the old days, even before virtualization, when you had a new application that you wanted to deploy into production, it was usually a service request. So the application owner would say, I need a new box, it needs X amount of RAM, it needs this number of processors, it needs this amount of disk with this speed of disk, it needs these connections to the subnet, different subnets, different networks. The concept here is, no longer do you need that request. The application owner can go to the self-service portal. They've already defined the requirements of their application and their workload, and the private cloud environment automatically places it based on those needs and those requirements. Excuse me. So what makes up a fast track solution? What are the different components? And the first thing we do is we build a guide that we refer to as the reference architecture. So this is Microsoft's best patterns and practices, all the knowledge we've learned, and this knowledge comes from various resources inside of Microsoft, including the product groups. So this is Windows, this is System Center, this is the various component groups within System Center. We also leverage, we call it the one tap. So when we were developing Windows Server 2012 and System Center 2012, we had a program called OneTap. This is our technical adoption program. This is a program where we engage with early adopter customers who are deploying the software prior to release. And we called it OneTap because this was the first time where we basically had all the System Center components together deployed at our TAP customer sites for a complete end-to-end private cloud. So we gained a lot of knowledge about practical deployment options, about configuration options for high availability, for security, for scalability. So we gained all that information from our OneTap, and we brought it into our reference architecture as well. And another key resource that we leveraged was actually our MCS, Microsoft Consulting Services. These are the guys out in the field engaging with our customers today who are actually building private cloud, customizing private cloud, and they really have where I tend to think a little bit, I'm from the product group, so I'm not trying to insult anyone from the product group, but at times product groups can be a little bit academic in their design. They can be a little more theoretical about how it's supposed to work, where you have MCS out there actually doing the deployment, understanding how the different System Center components really scale, understanding what their fault tolerance and high availability needs really are. So we gain that knowledge from MCS as well. Out of these practical deployments, we brought that into our reference architecture. So our reference architecture has already made the decisions around different size private clouds and different goals around private clouds, how to build the solution in the environment. So the first thing we have is this reference architecture guide, and then what we did is we have large blank sections for our OEMs to fill out. So we go into the detail and talk about the hardware requirements. We talk about the requirements of what the compute, networking, and storage must do. And then we almost treat this documentation as our application form. We give it over to our OEM partner who wants to build and validate a fast-track solution. They then fill out these blank sections and talk about how their hardware is going to meet these needs, how their value-add software is going to meet these needs. And at that point, that application form, oftentimes it's an iterative process. They fill it out. We have questions. We tweak things. Then we have on paper the design and the architecture and what's going to be built out by the OEM. Only at that point that we've come to mutual agreements or mutual acceptance do we actually then allow the OEM to go and build out the end-to-end solution. And that's exactly what they do. We take it from a reference architecture into a reference implementation or a physical implementation. So the OEM then builds out the entire thing. Occasionally it happens in our labs at Microsoft. Most often it happens at our partner labs. They build it out. We do testing. We do smoke testing. We do scenario testing. We do some scale testing and perf testing as well. So usually we send resources out to the OEM, and together we test this entire process. The outcome of this is not only now we have a reference architecture with the OEM, we have a physical build-out with the OEM, but we also build a complete end-to-end build guidance, which also tends to be many, many pages, if not hundreds of pages, to make sure that this is a repeatably deployable solution. That from end to end, we can lay this thing out from the bare metal hardware to the hydration of the Windows stack, System Center stack, all the integration components as well. And that's one of the key things we always focus on is repeatability. It's great to say that we can do it one time in a lab, but every time that an SI or the OEM or consulting org goes out to deploy a fast-track solution, can it be done fast? Can it be done reliably? And are we assured that it's going to work upon deployment at the customer site? So just a little bit of a brief history about the evolution of Fast Track. As I mentioned, we're in version 3. Our first version was launched a few years back based on Windows Server 2008 R2 and System Center 2008. 1 year ago, here at MMS, we launched version 2, which was based on Server 2008 R2 and System Center 2012. And what we're launching here this week at MMS is version 3 based on Windows Server 2012 and System Center 2012 Service Pack 1. And as I mentioned, these are validated designs that include System Center management. It is a physical solution ready to integrate and drive business value. And it's a combination of not just the Microsoft components, not just the OEM hardware components, but the whole stack end to end. And again, not only did we bring in resources like MCS, the one-tap, the product groups, but when we looked at our design choices, we really thought of the different things, the voice of the customer. What's the customer asking for? What are their design needs? We talked the voice of the business. What makes business value and business sense from a private cloud environment? And of course, we thought of voice of the technology as well. With both Windows Server 2012 and System Center 2012 SB1, there's a lot of new technology adds. There's a lot of advancements, and we want to leverage those to really provide great technical and business value. So we changed this a little bit in version 3, so I want to spend just a minute talking about how version 3 differs. In version 1 and 2, we've always kind of considered 3 different market segments or 3 different sizes: SMB, small and medium business solutions, enterprise solutions, and service provider solutions. So it's almost kind of small, medium, and large. In version 1 and 2, we only focused on enterprise solutions. And our typical host configuration was between, here it says 4 to 16. Most of our configurations were actually more like 8 to 32. That was kind of the sweet spot. But now in version 3, we wanted to blow this out a little bit more. We saw a lot of demand and need for smaller configurations, as well as for our hosting partners, very large configurations, where we're talking hundreds potentially of hosts. So in version 3, we've now broken it off into Fast Track Small, which is really targeted between 2 and 4 hosts. And I want to be clear on Fast Track Small. Calling Fast Track Small a private cloud is frankly a little bit of a misnomer. It's a little bit of an exaggeration, if you will. We don't have any system center stack in Fast Track Small. It's all based on built-in tools. So it's based on Server Manager and Windows Server, based on Virtual Machine Manager, Cluster Manager. So some of these things like orchestration scripts, chargeback reporting, they're not present in Fast Track Small. So I tend to think of Fast Track Small, I call it more of a virtualization appliance or a consolidation appliance. Tends to be a half-rack unit. It's an opportunity for a customer who wants to start out, just needs a little compute, a little network, a little storage, wants to start out simple. This is a solution that we've targeted for them. Fast Track Medium is similar to the scale and scope that we had in version 1 and 2, really targeted around 6 to 64 nodes. And then Fast Track 3, this is to be announced. We don't have anything at this time around the hoster environments. It's something that's currently being investigated and being developed. So over the next several months or beyond, you'll probably hear more about it. But in version 1 and 2, version 3, Fast Track Small and Medium, we have those today. And we have solutions that we'll be talking about that target both the small and the medium space today. Just briefly, this is the V2 solutions, or the V2 partners that we had. So this is the things that we launched a year ago. These are out in the market today. You'll actually see when we talk about our current partners in V3, we have even more partners than this involved in V3. But in V2, we had various solutions from NEC, NetApp, Hitachi, Cisco. Even the NetApp solution, we had a couple different options. They also built our very first VDI-specific private cloud. So it was a customized infrastructure that was specific for the VDI workloads. And we had a lot of great traction and utilization out of the Fast Track solutions in V2. Last thing I want to mention is a lot of our guidance in V2, the last version, based on Windows Server 2008 R2 and System Center 2012. All of this great guidance that we created and we used to only keep between us and our OEM partners is now available on the web. So if you are a do-it-yourself or you want to understand some of the more intricate design points of what Fast Track is, our operations guide, which is the last thing, the operations guide I haven't talked about much. That's actually the guide that we tend to give to the customer to talk about how you operate the Fast Track solution once you deployed it. But the build guide, the reference architecture guide, and the operations guide for version 2 are available on the web, and that's the link. Are we going to also release our current guidance for version 3? The answer is yes, but it's probably still a few months away. Right now, we're still working on it. It's still just between us and our OEMs as they're validating, but in the next few months, our goal is to make that publicly available as well. All right, so with that, I'd actually like to invite up Adam Fazio. As I mentioned, Adam is one of our chief architects who is responsible for the design of Fast Track and the reference architecture. So Adam, thanks a lot.
Thanks, Brian. Welcome, thanks for being here. My name is Adam Fazio. I'm a solution architect in our Worldwide Data Center and Private Cloud Center of Excellence. I have been working on the Fast Track program since its inception with Brian and several other folks involved in the program. So now we're going to dig into some of the meat. First, I'm going to run through the small solutions, so what's in market today for the small configurations. I'll then run through the architectural principles and a little bit of a deep dive on the actual design elements that go into medium. And then I'll go through the medium solutions. Several of these OEMs that have solutions for Fast Track are here this week, and I strongly encourage you to go check them out. They have their fully built out solutions there and all of the special sauce they put on top of that to make it really, really exciting, and they can show you those things. So first of all, the small config is really two different design elements. The first on the left here is the cluster in a box. This is some really cool hardware innovation has gone into this. Cluster in a box are generally based on a clustered RAID controllers. So first of all, you have a single chassis with two sleds for high availability. And then you have clustered RAID controllers that connect to a series of disks underneath. So that's some of the new hardware configs. You can go on Channel 9 and look at a session or two on cluster in a box, and there's some really, really cool stuff happening there. And then, of course, we have our traditional clustered SAN solutions. These are NAS or SAN devices that are connecting via iSCSI or fiber or SMB. So we'll run through some of the small configs in market today. First up, we have Cisco and EMC. This is based on the VNXE storage line. So it's network-based storage, either iSCSI or SMB3 connectivity to the storage. On the Cisco side, we have the blade or rack mount UCS solution. And then, of course, the Cisco Nexus networking switches in there. You can see as you look at some of the specs, and I'm not going to run through all the specs on all these slides because that would put you to sleep. But you can see some of the configuration choices that you have at purchase time are pretty interesting. You can start out small. You can go all the way up to hundreds of terabytes of storage if you need that here. Next up is Nimble Storage and Cisco. So Nimble Storage decided to use just the Cisco UCS C series, so the rack mount servers only. And then they have their Nimble Storage CS in this solution. I didn't see a Nimble booth on our expo floor, but they are definitely a tight partner and have a really interesting solution, so be sure to check that out. IBM actually has three small solutions. IBM, of course, having no shortage of hardware that they sell, so they wanted to get a lot of that into these predefined solutions. So first up is based on the IBM Flex system and their V7000 storage. So this is a fiber channel over Ethernet-based storage and tightly integrated. Like Brian said, these are really virtualization appliances. You drop ship them, you turn them on, and you start using them. Next up is their, so the main difference here between this and the last one is the storage connectivity and the choices around storage. This is still the same IBM Flex system compute, but on the storage side, it's now iSCSI. You have N number of 1 gig ports you can turn on to get the throughput that you need, and it's based on the DS storage. And then lastly, we have a change in the type of compute nodes that we're using. So these are your IBM rack mount type of servers, again with the DS storage. So some good choices there. And then in the hopper for small, we are working closely with Fujitsu. They will have something in market very soon. And we're excited to launch this based on their Primergy platform. So take a look for that probably in the next month or so. So medium is really where a lot of the heavy lifting for the architecture and design work comes into play around formulating a private cloud and bringing those principles of being actually a cloud service provider into the architecture. So I'm going to now run through some of that process with you and then get into the solutions themselves. So first of all, a little history. About 3 or 4 years ago when we started working with Brian's group, We had a series of documentation that was produced. It's now published on TechNet. I would highly encourage you to take a look at it. We have a private cloud solutions hub on TechNet, and the articles I'm referring to are the principles, patterns, and concepts for private cloud. Those papers were published as part of a team's work of working with GFS, which is our organization that runs our global data centers, that run services like Azure, Bing, Hotmail, very, very large-scale cloud computing systems. And this team's charter was to go find out how do they do what they do at very, very large scale for very low cost, very high efficiency, extremely, extremely efficient, cost-effective, highly available, basically dial-tone infrastructure services. How do they do what they do? What are the core design elements that make that work? And so what the model sort of summarizes that process. So the private cloud reference model defines all the layers. It's this very holistic model that defines all the layers that constitute how to operate as a cloud service provider. Specifically, Fast Track focuses on infrastructure as a service. So that's really the focus of today. So starting with the infrastructure, as Brian said, we have storage, network compute, and the virtualization layer. We also have some facilities management as well that we look at. That provides services to the platform and the software layers. Up in the service delivery layer, it turns out that certain things are really, really important when you're becoming a service provider. Things like financial management. Even if you have no interest in ever actually charging back the business units for the IT services they're consuming, having that principle of cost transparency, of really understanding what the costs are per gigabyte, per compute, per network port to operate and maintain the environment long term, and providing that cost transparency back to the people consuming it is a very powerful part of being a service provider. So there are certain elements in the model that it turns out are really important. Some are really good ideas for certain industries, but are not absolutely critical to being, operating like a cloud service provider. And so those are the learnings that we try to bring into the Fast Track architecture. So on the operations side, these are elements that really come from frameworks like ITIL, MOF, DevOps, whatever framework that you're using. We try to surface some of those operational considerations in things like change management, incident and problem management, access management, request fulfillment. So after you've done your infrastructure work, how does the end user who's consuming the resources get notified that it's been fulfilled? How does he then access and consume the resource? And then finally, the management layer is really your traditional systems management that you know and love about System Center. Things like fabric management. It turns out that there are certain things you got to do in managing the fabric as a cloud service provider to have that concept of continuous availability really function. There are certain things you can do to really enable that principle within your fabric management layer. So take a look at that documentation. As Brian said, there's 3 sort of configurations in Fast Track now: small, medium, and large. So it turns out as you get up into the hundreds or thousands of compute nodes, you need to be more and more standardized, more and more prescriptive about the architecture. On the small side as well, since there's very little systems management there, we can be very prescriptive. But in the medium config and your enterprise config, we try to be a lot more open and flexible. So it's a balancing act. And each time we've gone through this design process, we belabor these topics and these design points. What do you have to do, what should you do, and what could you do? And that's where we come up with our validation criteria. And like I said, each time we go through this process, we have these criteria that we define, and we debate both with the Hyper-V team, with our knowledge from the field, working with customers, and also when we release the guidance and work on it with our OEM partners. What are the sort of things that you absolutely have to do? What are the things that are recommended best practice that really will differentiate you, but they're not critical to the architecture? And then optional things that are really going to light up the solution, but don't have to be included. And when you put this together at the end of the day, in each major section of the reference architecture, you come up with basically a giant rule set, and this you can use to validate solutions. So digging a little deeper, this is sort of what the architectural overview looks like from a high level. So starting at the bottom, we have the fabric, your virtualization, your storage, your network compute, your hardware. And then moving up the stack, we start with automation. These are things like PowerShell and WMI that allow us to do the orchestration in the hardware stack. The management layer, orchestration, that is sort of the glue that binds these layers together. Service management, really important functions around how do I operate as a service provider, and then of course providing that self-service experience to the consumers of the cloud. Oh, I lost my water somewhere. Thanks, Brian. So as Brian said, it's an iterative process, working closely with the RDP and TAP teams, and these are some of the scenarios that were introduced during those programs. Just to give you a little bit level of detail around sort of the key scenarios that are enabled and that we try and focus on in the solution. So starting with the service provider, you can see some of the functionalities that, or some of the functions that the service provider needs to do. The fabric provider. Service provider, these are often the same roles, but don't have to be. You might have someone who is your data center administrator who's really constructing the fabric, and then someone who is actually constructing templates and doing lifecycle management of the services that are riding on top of the fabric. But oftentimes that can be the same team. And then finally, the service consumer. What are sort of the key functionalities that a consumer of a cloud needs to be leveraging? And you can see the enabling technologies on the right. We really focus on sort of 5 core system center products in the stack. So I'll dig into these in more detail. So those are the key scenarios. Digging into the fabric architecture itself. So this is how do we actually construct from the ground up, from bare metal to the virtualization layer. And what we came up with was 3 main architectural patterns. Continuous availability over SMB storage. That is basically a fancy way of saying file-based storage for virtualization. This is running your VMs on file shares using the SMB protocol in Windows Server 2012. Then we have converged infrastructure. This is where your network and your storage network are using the same set of cables. And then your non-converged. Starting with non-converged, this is basically your typical dedicated HBAs for storage, dedicated NICs for network, dedicated switches on each side. The emphasis here is if that is your architecture in your data center, it's a low risk, simple way of getting a fabric in there that adheres to that, can leverage that backbone that you already have in place. And this is optimal if you want to leverage some existing investments and existing operational mechanisms that you already have in place. Converged infrastructure, this is where we were talking about systems like Cisco UCS or HP Matrix. Usually we're talking about blade systems that are using a converged fabric, so storage and network are running over the same set of wires. This is usually converged or non-converged is a much larger design choice for the data center all up. It's not necessarily something you want to embark on in a small way. You can, of course, pilot this technology, but you'll find that as you grow this out, you'll need to have made that decision, that architectural decision at a data center level, kind of all up. So this is we try to articulate some of the benefits and business drivers in the fast track guidance around why you would leverage one of these architectures over another. And then finally, continuous availability over SMB. This is a really exciting design choice that we are bringing to market for the first time with Server 2012. And there's several different ways you can deploy this. One way is to use actual Windows file servers as your storage subsystem. And you present shares to Hyper-V, and the VMs actually run on the shares. The Windows file servers then can do, using things like storage spaces and SMB Direct, can actually manage the disks, the individual disk drives themselves, and present pools of storage, LUNs, etc., at the file server level, and finally to Hyper-V. So that's one way. If you wanted to build your own storage infrastructure, you can do it at extremely low cost and do some really cool things there. However, many people have existing storage investments or existing storage vendors or techniques of doing things that they want to leverage, and that's where our OEM partners are also have solutions using SMB3. So NetApp has an SMB3 implementation with their data on tap, EMC, etc. And so then you can basically continue to use your existing support and operational procedures with your existing storage vendors and leverage this file-based storage technique. And then finally, if you have very large SAN arrays, and one scenario is having a very large SAN array, but you don't have the SMB protocol in there, you can front-end that SAN array with Windows file servers. So there's sort of 3 different choices there. This is obviously, technically, this is a converged infrastructure because your storage is running across Ethernet, usually sharing the same fabric as your network adapters. But we call this out specially because the main difference is block storage versus file storage. Moving on to management. I hope that one thing you saw with the private cloud model, the reference model that I showed you, was that the fabric was just the small corner, and really everything around it is what constitutes a private cloud. And so that's where the management system becomes really critical. So this is another design choice now. What I'm going to show you here is a reference architecture for an enterprise deployment of System Center to do just private cloud. I know that System Center can do a lot more, and there's a lot more products, and it can be configured and deployed in a number of different ways. But we are basically releasing the reference architecture as a prescriptive way to do System Center to operate a private cloud in a highly available way in a production environment. So that's what this is about. And we start with a 2-node Hyper-V cluster dedicated just to management. So using the same principle as a large-scale SAN would use with 2 dedicated storage controllers, we want 2 dedicated nodes. We do this for a variety of reasons. We've gone back and forth on this over the years, but I think this is where we are today for large-scale compute. So to get the availability and performance guarantees that we need and to not impact other production workloads on the fabric, we have 2 dedicated management nodes. And then we use a different high availability techniques depending on what's available in that System Center component. So starting at the bottom, we use Hyper-V host clustering. For these workloads, we have 3 service manager servers. We have a management server, an additional management server, and a data warehouse. We then have the service manager portal. That is the self-service experience based on SharePoint. Then we have operations manager reporting, and then an optional Windows deployment server. That's for doing things like bare metal provisioning using the System Center products. So the following components have actually native high availability built into them. They don't need to be host clustered. They can just have redundancy across the cluster and stay where they are. So that's basically 2 operations manager servers and 2 orchestrator action servers. And then lastly, these components at top use traditional guest clustering. So they're doing Windows Server clustering inside the guest to achieve high availability. This virtual machine manager has 2 there, and then we have our SQL cluster nodes. We really only require 2 SQL servers. This is just illustrated to show that as your environment grows and you need more SQL for different management systems or whatever the case may be, that you can scale that out. Now, finally, with our deployment guidance, this is just something that I draw up typically for customers to help them understand what this really looks like at the end of the day from an integration perspective. How do these products all tie together? So if you were just to go to install what I just showed you, logically, this is what you would end up with. You have all your System Center components. They kind of really don't talk to each other yet. You have Active Directory. You have your data warehouses. You have Service Manager and the configuration management database that it provides in the middle there. And then up top, you have your public cloud solutions, and then at bottom, you have your fabric, your on-premise fabric. Next, you have native ability just built into the products to integrate. So very simple to integrate App Controller with Virtual Machine Manager, which then manages your Hyper-V systems, and Azure. You type in a username and password. In Azure's case, you do a certificate exchange, and now you're good to go. Next, we have reporting data. So these connections basically send reporting data on a scheduled basis over to the data warehouses. Finally, I know it's hard to see, but these are our built-in integration connectors for Virtual Machine Manager and Operations Manager, which both deploy agents onto the Hyper-V hosts. That allows for things like dynamic optimization. It allows for things like automatic discovery of anything Virtual Machine Manager manages over into Operations Manager for performance and health. Finally, we have these things called configuration item connectors. So if you're familiar with any ITSM, this will be familiar to you. This is where we pull objects from these systems and populate our CMDB with them. This allows the service management system to understand the relationships between these objects. So when you build a cloud in Virtual Machine Manager, and it constitutes some network and storage, some logical networks, it maybe is assigned to a specific set of users. Those users, those objects, all that data is surfaced in the CMDB, and you can use that to build out your service catalog. So you can say, user X can request services on this cloud, which has this SLA, et cetera. And then finally, we have our orchestrator integration packs. There are a lot more CI connectors and integration packs available, by the way, within the product suite. These are just the ones that we absolutely have to have a fully functional private cloud system based on System Center. So there is an Azure integration pack, there are other integration packs, and there are additional management packs also with our partner OEMs. Again, encourage you to check those out because they're pretty cool. Normally, I would stop there and we would have a discussion based on all that stuff, which would go on for quite a while, but we have to move on here. So before I get into these solutions, I want to mention, so not only are these hardware partners here showcasing these solutions, some of them are also here in the room, and I encourage you to come talk to them after the session, as well as myself. And then, as I just showed you, that integrated architecture is on display both at our services booths on the expo floor. Also, I know that like Cisco NetApp, for instance, they have their PowerShell and their orchestrator runbooks on display as well, and they've done some pretty cool things with those techniques. So first up is the NetApp and Cisco solution. This is based on FlexPod. So this is using Cisco UCS blade and optionally rack mount servers. Again, with the Cisco Nexus family of switches, including the Nexus 1000V, the virtual switch extension for Hyper-V, and using NetApp fast storage. They actually invest quite heavily in some of the value-added services on top, so the management packs, the integration, and additional runbooks that you can use. For instance, during validation, they showed me one runbook that can bare metal provision a blade, from nothing to a fully functioning Hyper-V cluster node in just minutes, using LUN cloning on the NetApp side and the server profiles on the UCS side. So some really cool stuff there. Cisco EMC also have a big presence this week here. You can check them out. Based on the VNX series of storage, those storage arrays actually offer Fibre Channel, SMB, and iSCSI, so you have a lot of choice there. You have the Cisco Nexus series of switches again, and then the Cisco UCS blade servers. So this configuration might look familiar to you with some of our competitors. We've worked with them very closely. We have a very tightly integrated stack here now as well. Really interesting solution. So those two are validated, ready for purchase today. Here are some that are still in the works. Actually, this particular system, if you've seen the Serverquarium that runs all of the MMS and the hands-on labs, that is a fast-track solution. We haven't gone through the validation process with them yet. We're there ready to right now. If that system wasn't running all of this show, we would probably validate on that system. So it's HP Blade Systems using their Virtual Connect Fabric, Fibre Channel SAN switches. I believe this is 3-PAR storage, I'm pretty sure. And a lot of convergence, a lot of advanced techniques that they use here. Also, Hitachi Data Systems. They have some very interesting hardware and some very interesting integration as well. And we're working closely with them now to validate as well, right? And finally, NEC. NEC is, their primary presence is in Asia. So it is a little bit of a language issue to get them through validation when they send a cluster validation report in Japanese. But very, very interesting hardware solution. Working closely with them as we speak to get this in market. So now, a little background. I've been with this program a long time, and I've talked to a lot of customers about Fast Track as well as our services offerings, which are based on the same offerings that MCS produces. And a lot of the feedback that I get is that's great. If I were going to go build a brand new data center or start a new company, and I just had concrete, I would put one of these things in, and I would use all this tightly integrated stuff you're talking about, and I would be very happy. But that's not my reality. My reality is today, I have hundreds or thousands of workloads that I have to somehow get, advance and evolve into this new way of doing IT. How am I going to get there? And so that's why Lavanya here is going to show you a couple of our free tools that can help you both do discovery and assessment of your environment as well as migrate to a Fast Track solution.
Thank you, Adam. Good morning, everyone. I'm kind of hardwired to the table here, so I apologize for not coming up. The first tool that I'm going to talk about is the Microsoft Assessment and Planning Toolkit. You heard Brian and Adam talk about the private cloud fast track solutions that we have. Then you would be curious as to how to get there if you have not tried it already, if you don't have a private cloud fast track solution in your environment already. So the Solutions Accelerator team from Microsoft has some really cool free tools that you could easily download from the Microsoft.com site, and you can give it a try. The Microsoft Assessment and Planning Toolkit is a phenomenal tool. It has two parts that it does. The first one is actually assessing your current environment. It is typically run on an environment for many days, sometimes even weeks, when it actually assesses all your current workloads and measures the utilization numbers. It identifies all the peaks and spikes in your environment and tells you all that you need to know about your current workloads. The previous versions of the Microsoft Assessment and Planning Toolkit, the MAP tool, started supporting Linux consolidation. It started supporting migrations into virtualization environments. And the recent ones specifically was modified for the Microsoft Private Cloud Fast Track solutions. So you could actually plan your future migrations into one of our solutions to see whether it fits your environment needs. If you see here, the tool actually supports a whole lot of different things like cloud, desktop, server virtualization, desktop virtualization, database, usage tracking, and environment. For the purposes of this demo and session, we are going to be focused on the private cloud fast track aspects of it. So if you scroll down here, you actually see a section on the Microsoft Private Cloud Fast Track. You go there, and here are the different things the tool actually does. Like I said, the first part of the tool is actually to collect the inventory data on your environment, collect the performance data, and analyze your environment. Typically, it takes a lot of days to run, so we are going to use pre-collected data from an environment for the purposes of this demo and focus on showing you how to use this tool to plan for your migration into one of the fast track solutions. So I go and click the Private Cloud Fast Track wizard. The first step here that you see is selecting the hardware configuration. So we have actually preloaded some of the sample solutions into the tool. Though these are sample solutions, these are actually real solutions that are existent in the market today. If you're interested in a particular OEM's solution that you want to give it a try, you could get the XML file from the OEM, load it into the tool, and the tool would plan your migration into that specific OEM solution. As you can see, we have a lot of different options. We have 6 to 12 node sample, we have an 8 node sample, we have 8 to 16 node sample, even more than what we show here. I'm going to try 2 different solutions here to show the difference and what the tool actually does and how you can make your decisions based on that. The first one is the Private Cloud Fast Track 6 to 12 node sample. I'm going to click View to show you what the solution is. As Brian and Adam mentioned, the fast-track private cloud solutions are designed to scale. So you could start with a very small base config, keep scaling up to suit your needs, and go all the way up to the maximum configuration of any given solution. So in this case, in the 6 to 12 node sample, the base configuration has about 6 hosts, 25,000 IOPS, SAN storage of 250 terabyte, and network throughput of 20 GPS. And you have different processors. The number of physical processors is 2, and you have 6 cores per processor. And if you scroll down, you could actually see the maximum configuration. And the number of hosts the maximum configuration supports is 12 hosts, and a SAN storage of 1,000 terabyte. So in this solution, you could actually scale from a 250 terabyte to 1,000 terabyte, and a network throughput of 10 GPS. So I choose this solution here. And here, the tool actually allows you to choose the utilization numbers that you want to plan for your environment. If you want the tool to only consider 50% of utilization numbers to plan, to keep room for future scaling up needs, you could do it. For the purposes of this demo, I'm going to keep it at 100%. And the next step is actually to choose a list of computers. You could either use the data that's collected by using this tool, or if you have data that you've collected using any other tool, you could actually load the text file here. So the environment that we had data from has about 325 machines. I'm going to select all of those for the tool to run. And here's the summary of the solution we have selected for the tool to plan migration into. It's the same 6 to 12 node solution. I click Finish. It takes a few minutes to run. So what you see below here is actually one of the solutions that I ran just for trial. So the page here actually gives you an overview. And one key thing that I'd like to call out is this is a completely agentless tool. It uses open source and APIs. You don't have it. You don't have to have it. Have a person manning it in all your machines. And it's available at Microsoft.com downloads, and it's very easy to download. It doesn't, the size is small. So here we go. Here's a quick overview of the results. This actually shows that for this particular environment, which had 325 machines, of which 314 were Windows machines, 11 Linux machines, 324 machines were actually placed into the solutions that you selected, and 1 machine could not be placed. Now, this is actually a very useful feature to have, because if you have a machine in your environment which has a specific hardware need or any special requirement that is not satisfied by the private cloud solution that you've selected, this would actually give you a warning, and you can look at other solutions. And the minimum configuration, if you go with the minimum configuration of 6 hosts and 250 terabyte storage, this actually says for this particular environment, you would need at least 2 of those solutions for your environment, and because you require at least 12 hosts. Now you can actually get a very detailed report. Here is the Generate Private Cloud Fast Track report. It gives you an Excel file that actually gives you the utilization numbers and how the different machines were different workloads were actually placed on the host. So the result is now generated. You go to your documents folder. There is a map folder that's created in your document folder. And here is the one we have just created. Now, as you can see, here is the summary that we actually saw before. 314 were Windows machines, of which 215 were Windows servers. The remaining were Windows clients. It also has the number of Windows servers from which we had the performance counters and inventory data collected successfully, the ones where we couldn't. And then we have the different numbers on the different other workloads, including the number of devices that couldn't be placed, number of devices that were placed successfully. I go on to the base config to quickly show you the report. Here, since we chose 100% utilization, the way the tool is designed is that it fills up every host one by one in the solution that you've selected, and then moves on to the next host to show you how much scaling up ability you have. In this case, you can see the CPU utilization numbers on each of the workloads in the host. You have the memory utilization numbers, you have the disk I/O, disk space utilization, network utilization, and here is actually the last placement failed reasons. What it actually says is that the host is full, now it's moving on to the next one. And if I scroll down, you can see that each of the hosts are filled to their maximum capacity. So we have 11 hosts that were utilized fully for the environment in question. We have only one host that is free if you need to scale up in the future, and that is why the requirement was 2 solutions if you're going with this particular solution, 2 packages. If you go to the maximum configuration, the data is exactly same. However, since the maximum solution and the maximum configuration actually has increased capabilities, increased memory, increased CPU performance, this actually are capable of handling, each of the hosts are capable of handling more workloads than the ones in the base config. So scrolling down. So you can actually see here that if you go with the maximum configuration, all you need is 8 hosts, and you have 4 hosts available for your future scaling up needs with just one package of the solution. That brings us to the end of the map tool demo. I can actually quickly show another solution for you, 8 to 32 node sample, just to give you the quick overview of how the solutions are different. So here, in this particular tool, you can see that the overview says that we chose a solution which is really high-end. It's 8 to 32 nodes, and for your environment, you just need one minimum configuration. So whatever you have, that the solution can scale up to is something that you can keep increasing your environment, scaling up your environment that will solve all your future needs. So we require only 8 hosts, and 1 private cloud is required for this. The next part of the tool, the next tool that I'm going to talk about is the Microsoft Virtual Machine Converter. So now you saw that you could actually analyze your environment. You could plan for future migrations into one of the private cloud solutions. The next step is how do you migrate your existing VMs to the Hyper-V VMs. If you are a VMware customer, you would probably like to try out before you go migrate your solutions into Hyper-V. This tool actually allows you to migrate your VMware VMs into Hyper-V VMs. And this is not just conversion of disks, but this actually converts both the VMs, which includes the entire configuration, from including how much of memory is assigned, what video cards are assigned, the NICs that are assigned to the machines. This is a very, very small tool to download. It's only 4.3 MB. It's very quick and low risk. The way the tool actually works is it actually takes a snapshot of your VMware VM, and then it uninstalls all the VMware tools that you have and installs the Hyper-V integration tools for a clean conversion. And then it also includes 2 parts. One is a very easily navigatable GUI-based wizard that could take you step by step, or it also supports command line-based conversion that you could use in your already existing automation workflows or Windows PowerShell scripts. And the way it actually proceeds about doing is it converts every single configuration into the VM in Hyper-V that both the machines, the source as well as the destination, will be fully functional, up and running if you'd like them to be at the end of the conversion. In the interest of time, I'm just going to walk through the screenshots of every step. And it's very simple to run, and I would strongly encourage that you give a try. Yeah. Go. So the virtual machine converter, it's a standalone tool, and it supports various guest operating systems, including Windows 7 and Windows Vista, Windows Server 2003 SP2, Windows Server 2008, Windows Server 2008 R2. And of course, the list keeps growing. The team is constantly developing. Here, we actually enter the address of your VMware server, which is either vCenter, ESX server, or ESXi server. Now, this page actually populates all the VMs that are present in your VMware machine. Now, the reason I have just two here is to show you the difference between the different VMs that you have. Here, as you can see, there is a little I on the left corner and under the demo VM. What it actually shows is that if you have that icon, I, the conversion will not happen, and it could be due to various reasons. In this case, the DNS name is not reachable, so it won't be able to do the conversion for you. We have the next one, which is the Windows Server 2008 R2 VM, which we would be able to convert. So I've selected the Windows Server 2008 R2. And in this page, you actually give the virtual machine name, and you actually connect to the virtual machine, which is and then you basically say whether you want your source virtual machine to be up and running at the end of your conversion, or whether you want it off, whether you want the final state of the destination virtual machine to be up and running, or do you want it off. For the purposes of this demo, I've kept it as off state. Here, the tool actually requires a temporary folder to do the actual conversion, because it copies every configuration details as well, and then the hard disk, everything into a temporary folder, and then builds the virtual machine in the Hyper-V host for you. This is a local folder that I have in my machine. And then you input the details for the Hyper-V machine where you want your destination virtual machine to be hosted. You log in and you give the path where you want the disk to be located. And as you can see, it queries the server every single time to make sure that the credentials are valid and you're authorized to do the conversion. And here it gives you an overview of what you've selected, what the source server is, what the Hyper-V host is, what the destination VHT path is, the selected virtual machine, and that you wanted both of them to be off when you're done with the conversion. Here, like I said, this converter actually converts the configuration as well. So it actually tells you what kind of memory is configured into your machines. Here, the video memory configured into the VMware guest machine is greater than 4 MB. It gives, lets you know that, and that it will be limited to 4 MB on the converted machine as well. The conversion begins. The first step is actually validating the guest operating system on the source machine, preparing the source virtual machine, which is actually by taking the snapshot so that it can restore the snapshot at the end of the conversion. It uninstalls the VMware tools on the source virtual machine. It downloads the VMware virtual disks from the source virtual machine into the temp folder. And then you can see the different steps, which is restoring the source virtual machine to the original state. So we don't want to impact any of your existing environment. And then we basically start deleting the snapshot of the source virtual machine. So it's almost like the tool never leaves any mark, once you're done with it. And then it actually shuts down the source virtual machine because we selected it to be in the off state. We start converting the VMware virtual disks and injecting drivers, converts the VMware virtual disks, and the process actually takes a few minutes to run. And here's the last stage where it's converting the source virtual machine. And here is actually the virtual machine has been successfully converted. You get this message, which means everything is good. The Hyper-V host, which has your converted VM, is HVDemo-1. The virtual machine is this. And the operating system is Microsoft Windows Server 2008 R2. Here it gives you a little snippet saying that your restoration is complete, and you can actually log on to your Hyper-V host, go on to your Hyper-V manager, and there you'll have your VM that you've converted. Here are some useful tools. The Microsoft.com site actually has some session recording, which is detailed usage of the tool, including the command line options. We'd strongly encourage you to take a look. It tells you step by step how to use the tool and make the maximum use of it. That brings us to the end of our demos today. Thank you very much, and I invite my colleague Brian here.
Thanks, Lavanya. Am I back on? There we go. So in summary there, thanks, Lavanya, that was really good demos. You can see we have Hyper-V Cloud or Microsoft Private Cloud Fast Track, and our goal is to make it as seamless and easy to get onto one of these solutions as possible. So a lot of people say there's various solutions from different OEMs at different scale points. What do I need? And that's really what the map tool is designed to do. It assesses your current environment, tells you all your workloads, both physical, virtual, Windows, and Linux, and then it maps it to a fast track configuration so you can see what your consolidation is going to be. And then the second tool is, okay, great, now I know how I can fit all my workloads onto a fast track configuration. How do I actually migrate some of the ones that aren't already on Hyper-V? And that's what this free tool is designed to do. And as Lavanya mentioned, it has both a GUI version, and it also has a command line version. So if you want to actually script large-scale conversions of VMware virtual machines over to Hyper-V, it can be done as well. So in wrap-up, let's talk again about what our objectives were and kind of what are we walking away with this session from. So again, I hope that you're now familiar with what Microsoft Private Cloud Fast Track is. We understand what the business value and proposition is. Our goal is to provide the best Microsoft and hardware partner private cloud solution that's been already tested, validated, configured, and ready to go. We have both small solutions and medium solutions that are available in market, and several that are still coming out over the next several months. So stay tuned for those as well. And understanding the underlying technologies. So again, Adam went into some of the details. We do have different design considerations. We have converged networking. We have non-converged networking. We have storage over SMB shares. And the goal here is different partners have invested their time, their energy, their money, their secret sauce into different of these technologies for different market segments. So we wanted to give the flexibility to say that, hey, IBM has great solutions in this segment, and another partner has great solutions in a separate segment. So there is some flexibility there as well. And then the ability to discuss the value proposition that is Microsoft Private Cloud Fast Track brings to the customers. Speed of deployment, reduced complexity, multiple OEM and partner solutions available. So with that, I'd like to say thank you very much. I hope this session was useful. We're going to do question and answers, but we're just, the three of us are going to be up here to answer any questions, so I encourage you to come up and engage with us. Also, we have several of our hardware partners who are delivering fast track solutions. Also, please come up with us as well. So if you want to talk to some of the different partners who are delivering solutions, they'll be available. We also are going to be down at the booth this week, and also many of our partners have booths here as well where you can talk to them about the solution. So with that said, thank you very much. I hope it was a great session. We enjoyed speaking with you, and have a great rest of the day. Thank you.